Find the equation of a line such that the triangle formed by this line and the coordinate axis has an area of 6 square units and the length of the hypotenuse of this triangle is 5 units. Okay, let us begin. So first we'll try to understand it graphically. So here we have the xy coordinate plane and we have a line L1 which intersects the x-axis at the point A and the y-axis at the point B. Okay, so here we clearly observe here that the line segment AB is going to form a triangle and it's going to form a right angle triangle. It's given here that the area of this right angle triangle is 6 square units and the hypotenuse is given as 5 units. So our goal will be to determine the equation of this line with the help of this information. So here to begin with, what we'll do, we're going to suppose that the equation of the line is given by x over a added to y over b equals to 1. So this is the equation of the straight line. This is the equation of the straight line. And here a and b are the x and the y intercepts respectively. So here we can suppose that OA that is equals to A, that means OA is the x-intercept, and represent OB by B, where OB represents the y-intercept of the straight line. Now it's given in the problem that the area of the triangle OAB, so it's given as 6 units, so it's a 6 square units. So this is given to us, and we are also given the hypotenuse AB. So AB has a length of 5 units. It has a length of 5 units. Fine. Now what is the area of triangle ABC? The area of a triangle is given by half times the base. So base here is going to be OA times the altitude. So altitude will be OB. So this is equals to 6 square units. So what we have here is half times A times B equals to 6, or in other words we can say that AB is going to be equals to 12. Okay, fine. So AB is 12 and we have here the hypotenuse given as AB, which is equals to 5 units. So here we can use the Pythagoras theorem. So according to the Pythagoras theorem, so this is A and this is B and we have AB. So let's call it C. So C is 5 units. So from the Pythagoras theorem we say that a squared plus b squared equals to 5 squared, which is 25. So we can say using Pythagoras theorem, using the Pythagoras theorem, we have a squared plus b squared, so that's going to be equals to 5 squared, or we can say simply equals to 25. So here we can make use of the fact that since AB equals to 12, this implies that B is going to be 12 over A. So let's substitute it here. So A squared added to 12 over A whole squared, that's equals to 25. We can say A squared plus 144 over A squared equals to 25. And multiplying throughout with A squared, we're going to get A raised to the power of 4 plus 144 equals to 25 A squared. Now we have A raised to the power of 4 minus 25A squared plus 144 equals to 0. What we have here is a biquadratic equation. So we can factorize it to obtain the value of A squared. So we're going to get A squared minus 16 multiplied to A squared minus 9 equals to 0. So A squared has got two values. A squared could be 16, or we can have A squared equals to 9. So here A could take the value plus or minus 4, and A could also take the value plus or minus 3. Fine. So let's find out the corresponding B values as well, since we already consider B to be equals to 12 divided by A. So here we're going to get 4 cases. So let us begin with the first case. So if we consider A to be equals to positive 4, then B value that is going to be equals to 12 divided by 4, giving us 3. Then we can consider A to be equals to negative 4. That in that case, B value, there's going to be 12 divided by negative 4, that's going to give us negative 3. This is the second case. Coming to the third case, we are now going to consider A value to be equals to positive 3. Then 12 divided by 3, that's going to give us positive 4. And then we finally have the fourth case where we have A equals to negative 3. Then in that case, B value is going to be equals to 12 divided by negative 3 is negative 4. We can use these 4 cases to write the equation of the straight line. So we're going to get x over 4 added to y over b equals to 1. So this is going to be one equation. Then we could have negative x over 4 minus y over 3 equals to 1. And for the third case, we have x divided by 3 added to y divided by 4 equals to 1. And then in the fourth case, we have negative x divided by 3 minus y divided by 4 equals to 1. Let's further simplify. Multiplying throughout, in case number 1, throughout the equation with 12, it's going to give us 3x plus 4y. That's going to be equals to 12. Now here, we're going to multiply throughout with negative 12. So that's going to give us 3x plus 4y. That's going to be equals to negative 12. Next, we multiply throughout with 12 to get 4x plus 3y equals to 12. And then finally, we're going to multiply, in case number 4, throughout with negative 12 to get 4x plus 3y equals to negative 12. So here we have obtained 4 different equations, and all of these equations are going to be such that they are going to form a triangle with the coordinate axis and having an area of 6 square units, and the hypotenuse in each of the cases is going to be 5.